All right, so 3-7 is about quadratic inequalities, okay? And we're going to graph them today, and we are going to solve them using algebra. So we're going to be repeating some things that we've already talked about this year, but we're going to be applying them to quadratics now. Previously, we did graphing inequalities with linear functions. So just like with the linear functions, when we are graphing the inequalities, you have to pay attention to the signs. Because if you have greater than or less than, and there's no equal to, do you guys remember how that affects the line? Yeah, it's dash. Great. And then because they're quadratic inequalities, they're parabolas. Okay, so you're going to have a dashed line if it's less than or greater than. And then if it is greater than equal to or less than equal to, that's when you have a solid line parabola. Okay, so your solutions for inequalities, remember that the reason why we do shading is because there's not one solution. There are many solutions that are going to make that true. Okay, an equation only has, if it's quadratic, 0, 1, or 2 solutions, or imaginary solutions. So in addition to graphing the curve, you have to shade the regions to represent all the possible solutions. Do you guys remember what we used to decide where we're shading?
Zero.
Yep, which is called a test point. Good. Okay, so we use test points to decide whether to shade, and then there's two possibilities. We're either going to shade inside the parabola or outside of the parabola. Those are the two regions. Inside the parabola or outside the parabola. So just like we did before, whenever we graphed a quadratic, we wanted to create a table where the vertex is in the middle. Do you guys remember the equation for finding the middle? Yep, opposite of b over 2a. Good. Opposite of b over 2a. Okay, so we're going to do x equals the opposite of 7, negative 7, which is 7, and then 2 times 1. So 7 over 2, which you can either write as 7 over 2, or if you want, you can write it as 3.5. Okay, you can decide. How do I find what the y value is when I know what my x is? Yeah, you just plug it in. Okay, we are also going to be utilizing our table today. Okay, so if this is 3.5, I can go up to 4 and then up to 5. So 3.5 is half away from 4. So if I go a half down, it would be 3. And then this is 1.5 way. So if I go down 1.5, I'd have 2. Just remember that this is going to be your vertex. This is your center value. Okay, so do you guys remember what you have to do in order to utilize the table? Yep, but before that. Okay, so you have to tell it what you're graphing. So we are doing x squared minus 7x plus 10, and then, yes, we're going to our table, okay? So what we're going to do is we're going to fill in our chart, but then we're going to do some analyzing. So at 2, we're at 0. At 3, we are at negative 2. And then, do I have 3.5 on there? No, so don't say it out loud yet, but I do want you to think about how we're going to find that. What do you guys think? How are we going to find the y? Okay, so yeah, you can change the table set, or you can plug it in, either one. So if you go to the table set, If you want to know what happens at 3.5, just tell it to start at 3.5. Oops, not 3 negative 5. Okay, and then you can go back to your table and it'll be the first one on there. Okay, so negative 2.25. So negative 2 1/4. Okay, but really I am going to try to deal with whole numbers when I can, so I'm going to just make it back to 0. Okay, so we are gonna graph this, but when you are graphing this, we are going to span the entire graph. So a lot of times you'll be given like a 10 by 10, so we're going to draw that here. So I have my y-axis. Have my x-axis. And I'm just going to go by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I have 2, 4, 6, 8. So those are going by 1s as well. Okay, and I do have graph paper, so if you need some before you leave today, I'll have you grab one, okay? Okay, so when I start graphing this, I have 2, 0. I have 3, negative 2. 4, negative 2. 5, 0. And then the 3 1/2. That's going to be right in between here. So I go negative 2, and then you're going to estimate where that 1/4 is. Okay? Now, if I only graphed this little portion, okay, I would be missing a huge chunk of the graph. So now, instead of just stopping at the 5 points, we're going to use our table to help us span this graph. Okay? So all I have to do is look on here. At 6, where am I?
4.
Yep. So I'm going to graph 6, 1, 2, 3, 4. Now if at 6 I'm at 4, is there another number I know that's going to be at 4? Yep. So if I went 1 over from here, I'm going to go 1 over from here. Great. And then at 7, I'm at 10. Now, usually you'll have that on there. So this is 9, this is 10. I'm just going to put a little dot there so I know where this is going. Okay, and then is the line solid or dashed? I know I already started it.
Solid.
Why?
Because it's equal to.
Yes, you have the equal to. So if it has the equal to, then it's the solid. Okay? All right. So then I'm going to connect this. And usually when I graph these, one, I'll use pencil. But 2, I'll graph like 1/2 at a time. So you do want it to be U-shaped, okay? So just be careful with that part. All right, now we're going to do our test point. So, like you guys said, a very common test point to use is 0, 0. That's because it's the easiest to calculate. So the only time you can't use 0, 0 is if it's not clear where it is. So you're either going to shade inside the parabola or outside of the parabola. So if you choose 0, 0, notice where the position is. So your test point, we can use 0, 0. It's clearly where? Yep, it's clearly outside. So when you plug this in, you are just plugging it into your original equation. For your notes, I'm going to show you that we're plugging it in for x. But if you can use 0, 0, when you're doing your homework, you really should just be able to say, okay, this is my test point, and then go straight here. 0 is greater than or equal to what? 10. Okay, so it's fine for you to just say test point, this is what you got. So is 0 greater than or equal to 10?
No.
Nope. Okay, so it's false. Okay, so remember, this means you do not shade 0, 0. Okay, so do not shade 0, 0, which is where? Outside. So that means I'm going to shade where? Yes. Shade inside the parabola. Okay, and that's why you want to span the whole graph, because if not, you would be missing all of these points. If I stop my graph here, do you see how you'd be missing all of these that are above the x-axis? You'd be missing all of these points. You'd be missing all of those. You have to shade in everything here. Everything inside. Okay, so 0, 0 is outside, so we're going to shade inside the parabola. Okay, do you guys think that you could do your step 1? So do your table. Okay, let's try that. So let's double check and make sure you started in the right place. So -1 should be in the middle. And then of course you can do the 0, 1, you can do the -2, -3. And then when you checked your chart for this on your graph, have you guys already done that part yet? What did you get for -1? Or have we not done that yet?
-4.
Okay, what about for 0?
-7.
Okay, what about for 1? Okay, good. So you at least have to have 5 points. Okay, without it, your graph is not going to be the right shape. So when you check your table and you go to 2, 2 was negative what? 31. Okay, so that's really large compared to these, so we can just focus on these 5 points to graph it. But that means our y, we're going to have to go by what? We're going to have to make, yeah, let's make our scale by 2s, okay? And then we'll be able to fit those all on there. Now, if I scale my y's by 2s, do I have to scale my x's by 2s? Or can the y and axis have different scales? They can have different scales, okay? So if I make my y's by 2, that's fine, but my x's don't have to be. So we're going to scale y by 2. Okay, so, and I write this here just so I know sometimes it's hard to see. So -2, -4, -6, -8, -10, -12. What do I do?
Your x is 1. If you make your y is -5. Oh my gosh. Oh my god. Yes.
Yes. So, and I recommend keeping the x's by 1s because that's what we did here. We went by 1s. Okay? Okay, so we're just going to scale the y's by 2s, and then I'm going to leave my x scale by 1. And then was there something else that you guys were going to ask me? Okay. All right, so then what we're going to do is we're going to plot our points. So -3, -16, -2, -7. So at -7, it's between -8 and -6. At -1, I'm at -4. And then remember, this is symmetric. So if you go over 1 and you go to -7, you go over 1 to -7. Over another one, down to -16. Now, is this solid or dashed? Dashed, because you just have the less than. Okay? So, you're just going to make dashes just like this. And then make sure, when I say it spans the graph, what you want is you want to go all the way to that edge there. All right, is 0, 0 a good test point for this one? Yeah, it's very clearly outside, right? The only time you wouldn't want to use 0, 0 is if it's really close to 0, 0 and it's kind of hard to determine. But your test point can be anything, okay? So I just want you to understand, the reason why you're shading is because if you pick any point in here, it'll make this inequality true. Any point that's shaded. If you pick any point on the outside here, it's going to make that false. So that's why we have to shade, because there are so many correct answers that satisfy an inequality. So again, when you plug in the test point, if you can use 0, 0, that should be something that's really, really quick. Okay, for your notes, I'm just showing you where you're getting that from, so you're not confused from where 0 is greater than -7 came from. But is this true or false? Is 0 greater than -7? Yep, it's true. Okay. Now, we need to identify where the 0, 0 is. 0, 0 is outside again. It's not always going to be outside, okay? But this time it is. So we're going to shade 0, 0, which is outside the parabola. So when you're shading, okay, when you have graph paper, feel free to like make a enclosed little box like this, so you don't have to shade your whole paper, right? The thing that you want to be careful of is when you are given the graphs and you have to span the whole graph, sometimes people will shade under here. You do not shade underneath this. Okay? This is like an umbrella that goes down to your feet. It protects everything underneath it. If I made umbrellas that went down to your feet, would you guys buy them? If umbrellas that went down to your feet were a thing, would you carry them? That's probably why they haven't made them yet. I just don't want you to shade underneath it. Oh, yeah. I was thinking a clear umbrella. Duh. I was thinking like does Wednesday Addams have a black umbrella? For some reason I picture her with a clear umbrella. I don't know. Who is Wednesday Addams? Alright. We'll have to do a pop culture education a different day. Okay, so the main story, my main point to the story is I don't want you shading underneath here. Okay, if you were shading off the grid, you would have to shade there, not underneath it. Okay, this is off limits. Okay? Okay, so one way to solve these is by graphing. So all the shaded regions are possible solutions. But you can also solve these using algebra. It's just based on intervals. So we're also going to learn that way to solve using algebra. So when you're solving using algebra, you move all terms to one side. The good news is sometimes they are already set up for you like that. Then you are going to factor. So that's something that we practiced. Okay, so we should be very good at the factoring process. And then after you factor, you're going to find what is called critical values. This is where each factor equals zeros. So find critical values. So I'll walk you through that. That's where each factor equals 0. Okay, and then you're going to express those as inequalities. And then just like we do a test value on the graph, we're going to make a table, and we're also going to pick test points. And we're going to determine if the inequality is true or false. Now, you will know what your solution is because it's going to be the intervals where the test points are true. Okay, it is going to be the intervals where the test points are true. Okay, so this is a multi-step process. I'm going to walk you through it. And then I told you guys before, whenever we're doing notes, that I align them to your examples in the book. Okay, that's why here we have example 1, and then this says mixed exercises because that's what it will say in the textbook. The directions will say to solve by using a graph, a table, or algebraically. Any of the mixed exercises that you're doing in your homework, you are going to solve algebraically. Yeah, so not the graph, not the table. This is what we're going to do. So anyone that's in the mixed exercises, those are using algebra, and that's how I want you to do it on your homework. And then, of course, you'll have some on your quiz that say solve using algebra. Okay? All right, so step 1 is move all the terms to one side. That means the other side should be what? 0. Okay, so we already have step 1 is complete. I'm just going to put yes. There, that's already done. Okay, step 2 is factoring. Yep. So we're going to make the 2 parentheses. And then when you factor, x squared has to come from x times x, negative 2. Okay, the only thing that multiplies to 2 is 1 and 2. Because it's a negative, you'll have one that's negative and one that's positive. So you want a negative 1 here. That means which one has to be negative? The 2, because it's bigger. You can always check with FOIL. So negative 2x, x plus 1 times 1 is plus 1x, so you get negative x, which is what we have. So we did that right. All right, now this next step is what is has a new name, but it's something you've done before. So the critical values. The critical values is when each factor equals 0. So if you have x minus 2, all you have to do is set that equal to 0 and solve. So what would x be? 2. The other factor is x plus 1. So if you set that equal to 0, x would be negative 1. Okay? So when you're making a table, you have to have these expressed as inequalities. And I found that the simplest way to do that is to think of these two on a number line. So I'm going to have you do that with me. So we draw a number line. Give yourself some space like I did. Okay? And then when you are making the number line, I want you to make sure that these are in numerical order. So what comes first, 2 or negative 1? Which one? Negative 1 is lower, so it comes first. Okay? Now, when you are expressing these as inequalities, these have split up the number line into how many sections? 3 sections. Okay? So we're going to look at the first section. Do you guys remember in Algebra 1, graphing on a number line? Okay, so this portion right here would be x is, and then see how there's no equal to here? See how there's no equal to?
Yeah.
Okay, so this is just going to be x is less than negative 1. This section is x is less than negative 1. Again, there's no equal to because there's no equal to here. All right, based on that, could you guys tell me what this part is? X is greater than 2. Okay, and then the part in the middle here is where you put x in the middle, and x has to be bigger than negative 1 but less than 2. So x is between negative 1 and 2. So you have 1, 2, 3 intervals. Oh, look, 1, 2, 3 spaces. So your intervals are just going to go in these 3 spaces here. Okay, so the first one is x is less than negative 1. Negative 1 is less than x, which is less than 2. X is greater than 2. Okay, so the critical values create these 3 intervals. Now, when you're using algebra, you're going to pick a test point and you're going to plug it into the inequality, which is x squared minus x minus 2 is less than 0. Okay, that's what you're plugging it into. And your test point can be anything except for your critical value that's in that interval. So when you're choosing a test point, you pick a number in the interval that is not a critical value. So for the test point, we're going to pick a number, any number in the interval that is not a critical value. And then we're going to plug it into the inequality. Okay? So your test point, this says x is less than negative 1. What's a number less than negative 1? Negative 2 is great. Really, the smaller the better because you're going to plug these in. Okay? All right, and then between negative 1 and 2. 0. Yep, you could use 0. What else could you use? 1. 0 or 1, both of those would be great. 0 is going to be a little bit simpler. Okay, x is greater than 2. What's a good one? Yep. Okay, now I like to plug these in using mental math. I think it's easier, right? Because it's negative 2 squared minus negative 2 minus 2 is greater than 0. So normally when I plug these in, I would do this part mentally. Negative 2 squared is 4. A negative times a negative. This would be plus 2. And I would just evaluate. Okay, so 4 plus 2 minus 2 is just what? Yep. So this says 4 is less than 0. Is that true or false? False. 4 is not less than 0. So I like to put a line through that. Okay, and then if I plug in 0, is it fine if I just plug it in and evaluate it? Okay, because what are we going to have on this side? Just negative 2, because it's 0 minus 2, so negative 2. Is negative 2 less than 0? True. Okay, and then when I plug in 3, when I say I do mental math, what I mean is I do 3 squared, which is 9, and then it's minus 3 minus 2, and then I just simplify. This is 9 minus 5, which is 4. I can do that quicker than I could even plug it into my calculator. So 4 less than 0. We already said that that was what? False. Now your solution is whichever one is true. So the only one that was true here was negative 1 is less than x, which is less than 2. And so that would be your solution. So that means all of the solutions for this particular inequality would have to be between negative 1 and 2. Okay, that's what would make that true. Okay, for B, I'm going to show you how to set this up so you don't have to draw your table every time. You are welcome to draw your table, and it will be like that on your quiz so that you can fill it in nicely. But I'm going to show you how to do it so it's not as much. Remember, your first step is always to move terms to one side. So I'm going to move this 1 over. So I have 2x squared plus x minus 1 is greater than or equal to 0. Once we do that, we are going to factor. Okay, and then if it starts with 2x squared, I have to have 2x and x. And then this one's actually pretty nice because 1's a prime number. What's the only way to get negative 1? Positive 1 and negative 1, right? Okay, so if you want a positive here, this has to be plus, this one has to be minus, and then check with FOIL. So negative x, 2 times 1, this is 1x, that's what we have. Yay! Okay, now your critical values are going to be 2x minus 1 equals 0, x plus 1 equals 0, and we just solve those. Again, I'm fine if you jump from here to saying x is 1/2. X is negative 1. These are your critical values. These are what splits up the number line. Okay, and then let's go ahead and do the number line, and I'm going to show you how to turn the number line into your chart, okay? So we're going to make the chart from this. What comes first, 1/2 or negative 1? Yep. So you have the negative 1 here, the 1/2 here. Do you guys see how this is equal to? So if it has the equal to, you're going to do that. Do you think you guys can set up your intervals at the top? So this part are all the values that are less than or equal to negative 1. On this side, it's all the values that are greater than or equal to 1/2. And in the middle is negative 1 is less than or equal to x, which is less than or equal to 1/2. Okay, so you have these 3 intervals. 1, 2, 3. Okay, those are our 3. Okay, after we do the intervals, remember how we pick the test points? I'm just going to call them TPs. And let's pick some test points. So what's a good test point for x is less than or equal to negative 1? Negative 2. Don't use negative 1 because it's a critical value. Because see how it's in both of them? Only one of these is going to be true. What's a good value that's between negative 1 and 1/2? 0 would be great. X is greater than 1/2? 1. 2 is fine too. Okay, so, and then I just make my table from here. Let's make it a little different. So what you're doing is you're plugging these into the equation. For ones like this, you can decide if you want to use this one or this one. I like to use this one because then they're all on one side. So 2x squared plus x minus 1 is greater than or 0. If I plug in negative 2, it's 2, negative 2 squared minus 2 minus 1 is greater than 0. So let's do our order of operations. Negative 2 squared is 4. 4 times 2 is 8. So this is like 8 minus 3, which is 5. Is 5 greater than or equal to 0? Yeah, so true. Yeah, we do. Yeah. Okay, and then when you plug in 0, again, this is one where when you're plugging in 0, right, you should be able to see right away this equation is negative 1 is greater than or equal to 0. Right? If you plug that in, is that okay? So I'm plugging it in here. 2, 0 squared plus 0 minus 1 is negative 1. Is that true or false? False. Negative 1 is not greater than or equal to 0. Okay, and then I'm going to plug in 1. So it's 2 1 squared plus 1 minus 1 is greater than or equal to 0. Okay, 1 minus 1 is 0, so this is going to be 2 is greater than or equal to 0. Is that true or false? True. Okay, so you can have more than one true interval when you're writing your solution. You guys think you know how we have to connect them? With the or. Because remember when we did this before, we were using the unions? We did some union stuff. This is what it is. So x is less than or equal to negative 1, or x is greater than or equal to 1/2. That is your solution. Okay? All right, so I only gave you 9 homework problems tonight, but you do have to do your graphs on graph paper. Okay, so go ahead and if you need some, I have some in the back, okay?